Hey everyone, I'm Shiv, and welcome to Maths for ML Intuition First. This series is an attempt of mine to understand the mathematics behind machine learning, just to just to learn how LLMs work. And given all the hype, I thought it was important for me to know the maths and not just know how to use LLMs. And and in this first video, I'm gonna talk about vectors because vectors are everywhere in machine learning. And surprisingly, what I thought was a vector is actually uh, like not inaccurate, but it was. So what I thought was a vector is an arrow with a magnitude and a direction. And most of us think that way. We think that when we think about vectors, we think about arrows in 2D or 3Ds, but a vector can actually be anything. It can be an arrow in 2D 3D space. You can represent an image as arrays of pixel and values, and then functions can also be vectors. And because as long as you can scale or amplify something, that thing is can be a vector. So in this first video, what we are gonna do is we are gonna look into one particular type of vector, and that is a 2 cross 2 image, and look into the pixels of a image. So what we will do is what I have here is a Jupyter notebook, and what I'm gonna do is I'm gonna look into a 2 cross 2 grayscale image. So every grayscale image can be represented by a number every pixel in a grayscale image can be represented by a number 0 to 255, where 0 is black and 255 is white. So what I have here is I have a 2 cross 2 image. So there are 4 pixels in this image, and the value of each pixel is written. So the first pixel is 40, the second is 120, and the third one is 255. And as I said earlier, 255 is white. And what if I change it to 0? You will see this is like black. But if I change it to 100, it will be lighter. So as we go from 0 to 255, it moves from black to white. And so I'm going to revert it back to 040 for now. Now what I'm saying is this 2 by 2 image can be flattened out into, what we can do is we can flatten it out into a single row vector. So this is what we do. It's a single row vector which has 4 dimensions. So all I have done is I have written down each pixel of the image in a single row, and we can then say, hey, this image can be represented as a 4D row vector. And that is where it gets a little when if you start imagining graphs and arrows, it's hard to think about vectors, but it gets a little bit unintuitive if you're only looking at a graph, because it's hard to imagine a 4D vector in a graph, like 4-dimensional space. In this case, what we have is a 4D vector which we are able to represent as an image. And now what we will do is we will just look at what does it mean to scale an image, to add different images into each other. So when I say a scalar image, let's say we want to make this image a bit darker. So what if you want to make this image a bit darker, what we'll have to do is we'll have to reduce the values right here, right? If I just reduce the values to like 20, 60, everything gets darker. So, or what I can do is I can actually multiply. So what I have here is, what I have done is I've multiplied the image by 0.5, and then I multiply the image by 2.0. So the first image, because we are reducing the values, we make it darker, and in the second image, because we are increasing the value, we make it brighter. And you can see the two pixels here are completely white, because when we multiply by 2, these two numbers are like higher than 255. So this is multiplication, and in the later videos we will see how what is scalar multiplication. But for now, I just want you to think that we can manipulate an image by multiplying a number with all the pixels. And similarly, what we can do is we can add two images into each other. This is also called image blending. So I have these two arrays here. This is the first image that we took, and then the second image, and when we add them together, we get this image at the bottom. The bottom two are black, and if I, for example, if I change it to 60, or I change it to 0, you can see we can see the color because it is less than 255 now. And this is adding two images into each other. But what we can also do is we are simply, like, if we start representing these images as these arrays, we can simply add these two arrays, and that's what I am also doing. We are just adding these arrays to show the blended image. And in basically this addition and scalar multiplication, these are also properties of vectors. This is why vectors matter in ML. Like, once data is a vector, we can do math on it. We can measure similarity, we can make it darker, lighter, move around the feature. Like in this case, our image, we can blend two images into each other by adding them together. And these, and in the future, you will see how these operations actually power a lot of models. So a quick recap, we were able to represent a 2 by 2 image as a vector, as a 4D vector. We also scaled and made the image darker, like by increasing its brightness and making it darker. And we added images into each other, we blended them together. In the next video, we will formalize what a vector space is and what are vectors mathematically, and the rules that make addition and scaling like possible in a vector space. And then in the future videos, we will talk about norms, inner products, and a lot more about vectors. Yeah. The notebook link is in the description. Thank you so much.